Welcome back to DellyMaths Concepts. We're going to be looking at an algebra question, but if this is your first time watching this channel, please subscribe to the channel, like the video, and drop a comment. Check. It says factorize the following expression completely. All right. So whenever you are going to factorize completely, we must use the highest common factor, or what some people call the greatest common factor. So what is the greatest integer that could go into 12 and 4? That's going to be 4. And then for the letters, it's n. So my highest common factor is 4n. So what I'm going to do is to, as you could see, I've isolated the 4n, then I'm going to introduce a bracket. What we're going to do is to divide 4n into these two terms, and the result, the quotient comes down here. So 4n into 12n to the second is going to give me 3n. 4n cancels here. So I'm left with minus m. So this is just for 1 mark. So it's going to be 4n into 3n minus m. There we go. All right. This P part of the question says that show that x over 1 minus x, then minus 4x is equal to, in our numerator, x into 4x minus 3 all over 1 minus x. Take my left side, which is x over 1 minus x, and then there's a minus 4x here. I'm going to put this over 1. I'm going to do a regular fraction. My LCM is 1 minus x. So when 1 minus x goes into itself, it goes into it 1 time. So 1 times x gives us back x. Then 1 into 1 minus x is going to give us 1 minus x. If I distribute this negative 4x inside the bracket, I'm going to have negative 4x, and then I'm going to have positive 4x to the second power. If I should simplify this, and then I'm going to rearrange it so that my 4 comes in front. So if I should write back my 4x squared here, but if I simplify this part, I'm going to get negative 3x. And all of this is over 1 minus x. In order to get the shape, we realize that the numerators, the denominators are the same already, so we're good. So what we want to do is to factorize the numerator. So I'm going to take out x as my common factor. X into 4x squared will have given me 4x. X into negative 3x will give me negative 3. And all of this is over 1 minus x. Hence, you've seen we end up getting it like that. We would have gotten the marks right there. Now, because we had this coming out, the question went further and it says hence. And whenever we see hence, it is simply suggesting that we're going to utilize our last response there to solve this problem. So basically, hence we're supposed to solve this. But remember that this part is actually this. It is actually x into 4x minus 3 all over 1 minus x. So my left side can be represented as this, and then I'm going to let this equal to 0. And from here, I'm going to solve. So what we're going to do is just to multiply both sides by the fraction. We want to get rid of the fraction. So I'm going to multiply both sides by 1 minus x right here, as you could see. And then I'm going to multiply over here by 1 minus x, just the same for balancing. But on my left side, this 1 minus x does cancel 1 minus x there. So what we're really left with here is x into 4x minus 3. And 0 times anything is still 0, right? So that's what we have right there. So if we should pick up still, continue. If two things multiply to give 0, let's apply the 0 product rule. It says that it's either the x is a 0 or the 4x minus 3 is a 0. In this case, let us solve to find x. We're going to add 3 to both sides. So this part is gone. So we're left with 4x is equal to 3. And if we divide both sides by 4, then we could conclude that x is also equal to 3/4. So the two responses are as follows. That one of the response is that x is equal to 0. X is also equal to 3/4. And these are the two responses. Let's continue working. All right, so at the C part, it says make V the subject of this formula. So what we have is actually P, which is equal to the square root of 5 plus VT. We're going to make V the subject. If you take a quick look, you realize that V is actually fully covered under the square root. So what we want to do is to square both sides of the equation first in order to get rid of that square root sign. And so on the left side, we're left with p squared, which is equal to, so the square and the square would have canceled. So this is now 5 plus vt. And then we're going to subtract 5 from both sides. So we have p squared minus 5 is equal to vt. And then divide both sides by t. So p squared minus 5 over t is equal to v. And that's making v the subject right there. All right, let us take a look at the last question. So this last question here is a variation question. And it reads, it says the distance needed to stop a car, D. So the distance needed to stop a car, D, varies directly. So this is important as the square of the speed S. These two variables are very important at which it is traveling. So a car traveling at 70. So let me write on what I have. So I have a speed here, a car traveling at 70 kilometers per hour, all right, requires a distance of, so this is the D for it, of 40 meters to stop. What is the distance when the car is traveling at 80? So the question is, so we have this as what we know, and then they want us to find out this. If what will be the distance required with a speed of 80 kilometers per hour. All right, so this is where we're going, right? Now, what we want to do is to first represent this idea with the formula of the day, because it's a direct variation. So for a direct variation, it says the distance to stop a car, D varies. So this is our first variable. So basically, so we're suggesting that D varies as S squared. So this is the idea. But in terms of an equation to represent this, the equation is going to be like D is equal to some constant of variation. I'm going to call it K S squared. So this is the equation. It says D is equal to KS squared. Now, in order to work the problem out, we need the constant of variation. In this case, I represented it by calling it K, right? So we're going to utilize our first response here. This is the first situation that we actually have two variables that actually worked. So we're going to substitute 40 for D. So we're going to say 40 is going to equal to K times 70 squared. So I'm substituting right there. So 40 is definitely equal to 70 squared is going to give us 4900 and then K. So in an effort to find K, I'm going to divide everything by 4900. So what we're left with is K. So now we're seeing that we have a value for K. So K is actually 40. I could minimize this. I could reduce this. I'm going to reduce it. I'm going to reduce it. So let us reduce this quickly. So it's actually 2 over 245, right? Or 4 over 490. So basically that's what it is, right? So 2 over 245 is K. So let us have K there. So now we're going to use that same formula in an effort to find D. Take a look. So D is equal to K, which is a constant of variation, which is 2 over 245. And we're going to multiply that by the speed square, and the speed is 80. And you're going to square it now. So all we're going to do is to put together our numbers. So if we square 80, then times that by 2, we're actually looking at 12,800. And this is going to be over 245. So let us divide this by 245. D is equal to 52.24. All right, so D is approximately 52.2 meters. So what this is suggesting that if a car is coming with a speed of 80 kilometers per hour and you apply that brakes, it's going to need a distance of, it's still going to keep running and then stop at 52.2 meters. That's what it is saying. Thank you for watching DellyMaths Concepts. And if you want more content like these, please come back. All right. Thank you for watching DellyMaths Concepts.